use and enables maintenance people without special surveyor knowledge to perform the measurement without compromising accuracy. It is made possible by the combination of a modern robotic theodolite, the powerful software and the unique accessory kit. The point where the greatest attention must be paid is in the correct setup. The theodolite should be positioned ideally where all the tyres can be seen, and that the places for the reference points have to be selected carefully. A safe and stable place for the theodolite has to be identified on both sides of the kiln. With a good sight of the kiln tyres, only 2 places for the theodolite, the so-called stations, are required to measure the kiln axis. The main components of the accessory kit are the target axle with the reflector prisms and the telescopic pole, the intercom headset for communications, the reference points with magnetic bases, the tablet PC with the TomTom software, the measurement studio. The reference points consist of 3 components. The base magnet, which creates a strong hold and maintains the position. The ball prism, whose center is measured by the theodolite. And between, the prism holder, which allows the adjustment of the prism in different directions. The reference points, sometimes also called common points, are needed to merge the measurement from different stations to one complete 3D model. They have to be placed where they can be seen by the theodolite from the different stations. The reference points should be widely spread in the kiln area. Look for stiff steel structures, preferably close to concrete foundations. Make sure the base magnets have a sufficient hold. Adjust the prisms into the direction of the theodolite. Any station should have 4 to 5 reference points in common to one of its neighbouring stations to achieve a high degree of accuracy. Do not attach reference points on thin, unstable or vibrating structures because the position might change during the measurement process. When the reference points are placed and adjusted into the direction of the theodolite, the most difficult part of the job is already done. Check if the theodolite is stable. Start it up. Align it horizontally by turning the adjustment screws. And connect it via Bluetooth with the PC. Create a new project, the Kiln Axis Alignment Measurement. And add the reference points to it. To avoid confusion, name the reference points in a way that cannot be misunderstood. Activate the camera to make it easier to find the points. Aim the theodolite to the first reference point. When it is ready, press the start button. The theodolite searches the closest reference point and measures it automatically. The coordinates are displayed in the table. Aim the theodolite to the second reference point. Select it in the measurement studio and press the start button again. The values of the second point appear. Continue until all reference points are measured and then save the file. The next step will be the actual measurement of the kiln tyres. For that, the telescopic pole and the target axle are needed. Mount the axle onto the pole and make sure that it is securely tightened. To measure the required points on the tyre, the assistant goes up to the pier and holds the target axle onto the tyre. The The PC user navigates to the tyre table and selects the tyre which will be measured first. Here, number 3. The prism in use needs to be adjusted to ensure it is orientated towards the theodolite. Aim the theodolite to the target axle. Get the confirmation from the assistant that he is ready and the target axle is running stable. Press the start button. The theodolite will find the prism on the axle and measure the position automatically. The first point from the tyre appears on the screen. We've got the first point. Move the axle up a bit, take the second point. When the target axle is running stable again, click Start to measure the next point.
Okay, I'm ready.
We got it. Next. It is recommended to acquire approximately 8 measurement points on each side of the tyre to ensure optimal surface coverage. When sufficient points are measured, remove the target axle from the tyre and save the file. Move to the next pier. Here, tyre number 2. All the tyres will be measured the same way. Try to cover the circumference as much as possible. In the software, select tyre 2 to be measured. When the assistant is ready, push the start button. Repeat the sequence until sufficient points are collected and then move to the next pier. Measure the remaining tyre. Here, tyre 1. In case a prism cannot be measured, perhaps because it is not visible or not sufficiently adjusted towards the theodolite, an error message will appear. Adjust the position or orientation and measure again. Note, there are no specific areas on the tyre where the target axle needs to be placed, but it is essential that both wheels have stable contact with the tyre surface while the theodolite is measuring. Now all tyres are measured from the first station. Save the file. To verify if the theodolite was accidentally moved during the process, the station is checked by measuring the reference points again. This is done automatically by clicking on Verify Station, and it will immediately tell if the location of the theodolite is still okay. With that, the first side of the kiln is completed and the theodolite can be moved to the other side of the kiln. Place the theodolite on station 2, its second location, from where the tyres and the reference points can be seen. Level the theodolite. Adjust the reference points to the new position of the theodolite. Add a new station and select the reference points to be measured. Aim the theodolite to the first reference point and press Start. The coordinates are displayed in the table. Continue until all reference points are measured. To be sure that the second station of the theodolite can be precisely merged with the first station, review the transformation error of the individual points. Prepare the target axle to be measured from station 2. Switch to the tyre window and select the tyre to be measured. All tyres will be measured from station 2 as done from station 1. The alignment check of the kiln axis is one of the most important measurements on rotary kilns or dryers with more than 2 piers. The straightness of the kiln axis needs to be within tight tolerances to minimize the stress in the shell and to distribute the support loads correctly among the different piers. Typical symptoms for misalignment are circumferential cracks in the shell near the middle tire. The ball swivel can be mounted between pole and axle to facilitate the measurement of points which are difficult to read. As soon as sufficient data is collected, the tyre centres are calculated precisely. How reliable the centre positions of each tyre is indicated by the reliability number, going from 0 to 10. Make sure that the reliability numbers are higher than 6 on all tyres. Don't forget to save the file from time to time. Check here as well if the theodolite remained in exactly the same position and was not accidentally moved. The results of the kiln axis measurement are immediately available. The deviations can be seen in the radar chart and in the 3D model. The values are shown in the table, Y in the vertical axis, Z in the lateral axis. Now, the measurement campaign is completed and further analysis can be done in the office. All the different measurements done with TomTom tools can be combined into one single file, whereby a comprehensive 3D model or a detailed report of the kiln can be created with just a few clicks.